All right, welcome guys. We're going to do a quick lab here. We're finding the average atomic mass of this fictitious element called beanium. So we can't hold atoms in our hands, but we can hold beans in our hands. We're going to pretend that these are atoms today. So I hope you guys gathered the data, and then after that, you guys are going to be responsible for making the calculations and finding the average atomic mass of beanium. So here's the lab. Hopefully you've been able to print it off. Again, I'm going to help you fill in these two sections of the data column, and then you'll have to kind of calculate the percent abundance and do the work on the back on your own. So the first thing, we have a large collection of different atoms, and each one of these different beans is representing a different isotope. So it has a different mass, even though they're each the same. They're each beans, but they're each a different isotope of that bean. So this nice key here matches up. So first thing we need to do is count up how many white beans we have. Okay, so I'm finding 9 white beans. Record that there. Next up, I'm looking for my small little black beans. Quite a few of these guys. I'll kind of slide them over on the paper so you guys can see them better. They're not standing out real well on the countertop. Group 5. Another group of 5. Another group of 5. Fourth group of 5, and 2 left over. So that's 5, 10, 15, 20, and 2 more. So we've got 22 black beans. Okay, next up, we're looking for the pinto bean. Kind of got the swirls of colors on them. Don't see very many of these guys. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 of the pinto. Small brown bean, kind of a weird looking guy. And I'm seeing 3 of these. Pretty quick count. Kidney beans are next. I think we all know those guys. Look like a kidney. Counting 10, 4, 8, 10. And finally, this small red bean. 2, 4, 6, 8, 10. All right, so you want to find the total of all those. You'll need that for this step here to find the percentage of each type of atom. But the next part I'm going to help you out with is we're going to use the scale here, the balance. Make sure we're in grams. Put the weigh boat on. Go ahead and tare it. There we are. And I'm going to find the mass of one of each of these atoms. Start back up here with the white bean. I'm seeing a mass of 0.35 grams. Next up with black beans, 0.20 grams. Next up, the pinto beans. These are kind of the camouflage looking ones. 0.34 grams. Oops. We'll call it 0.35 grams. We're finally settled. The small brown, so the wrinkled ones, an even 0.50 grams. Kidney beans. Point five up. Often when it does this, the batteries are kind of going low. Well, I think we'll be all right recording that as 0.56. And finally, the small red bean. .30. All right, I'll put 0.31. Okay, so I've gathered the data with you. You should have these down for those of you at home. Your next step is you're going to want to find the percent abundance. The way that you do that for each type of atom, for the white bean, so there's 9, and you want to divide that by the total number of beans in the cup. Now, I'll point this out. Significant digits, you want to round to the 1,000th place. I'll watch you guys round to the thousandths. When you get to the backside, then you're going to find the average atomic mass, which is a weighted mass. I'm going to add in here the word mass, because a lot of people were just using their count and not the mass. So once you found your average, you're done with this column. You don't need this column anymore. When you get to the backside, make sure you're always finding the mass of your 6 isotopes. Show all your work. Don't forget to show that addition step in the middle. Watch your significant digits. And there's a couple of questions to answer. As usual, if you guys have any questions, send me an email. Take a look at this, and I'll see you when you get back.